Hey everybody, welcome back. This is video 6. In this video, we're going to fix the problem we're having here. So we got this, and we've got all the bots working, which is awesome, but they're all going off the screen, and more importantly, none of them are following this run sequence that we created here. So we need to fix that so they actually do follow the run sequence. So inside of Bot Manager, in the update bots method is where we're going to do all of this. And every time we go through and loop through and update all of our bots, we're going to check for two things. First thing we're going to check for is the bot at its destination. If the bot's at its destination, then go ahead and update the destination. Pretty easy. Otherwise, if the bot is at a boundary, then update the destination. Otherwise, update your movement. Okay, so when the bot gets to where it's going, which is the current destination XY, which we set when we update our destination here, and then we change the direction based on that new destination. It's also just the next thing in our run sequence. When that happens, when we make it to where we want to go, we go to the next destination. And once it gets to the end of all of our genetic code, it goes back to the start. Now, when we get to the boundary, you might be thinking, just turn the bot around and make it go the other way. But we want it to follow the code that we're giving it, the genetic code we're giving it in our run sequence. So we're going to see if the bot is evolutionarily capable of turning itself around. So we'll go through until we find something in there that lets the bot turn around. Now, it may never find that. The bot may be stuck in the upper left-hand corner, and the only directions it has is telling it to go up and to the left. And that's fine, because eventually that bot will run out of food, and that bot will die. So that being the case, the bot will not make it to the next generation, and we'll be breeding the more sophisticated bots that stay inside of the screen. Okay, so let's go ahead and make these methods. Let's do the first one here. Is at destination. We pass in the bot, and this is actually going to be pretty easy. We're just going to take the distance from where the bot currently is to the destination, and if that distance is less than 1, then we're good. Now you might be saying, wait a second, I remember back here when we created our delta x and our delta y, we used random integers. Why would I need to check less than 1? Why can't I just check if bot.x and bot.y is equal to destination x and destination y? Well, the reason you can't do that is because when we update the direction, delta x and delta y become floating point variables, which means that you're adding 0.3567 or whatever each time you move the bot. So this variable, this xy variable, is no longer an integer, it's a floating point number. And as the bot moves towards its destination, it's going to get very close to that destination, but it's never going to get exactly there. And it's going to get within 1 pixel, so it's going to be less than 1, or less than 1 pixel to its destination. So to do that, I'm going to say is square root, and it's going to be bot x minus bot dot destination x, and power of 2. This is once again me just using the Pythagorean theorem, and bot dot, well, actually, you know what? Forget that. Let's just copy this. Do that. And less than 1. Bot dot y and bot y. There we go. Good. Move it back. And if it's less than 1, then we return true. Otherwise, we return false. Okay. All right, so now that the destination is good, let's go ahead and do is at boundary. Takes in the same parameters. This one might be a little bit more complex. We've got if.bot.x plus bot.delta_x is less than 0. Okay, so what we're doing here is we're saying if the bot x, and now remember, when you're looking at your circle, it's going to be at the top left of the screen where bot x and bot y are. That's the position that it's drawn from. So if the bot is at the very top left of the screen, as far as it can possibly go, the x and y value will be 0, 0. Now if the delta value plus that is less than 0, then we want to turn around, or we want rather to go to the next possible destination in our run sequence. Okay, so let's go ahead and return true. Now you can put an OR statement here and do the next one if you want, but I like to put them on 2 different lines just in case. If it hits this one, it doesn't have to call this one as well. It doesn't have to compute that one rather. Plus bot dot diameter, and if that is greater than self.window dot width, then also return true. Okay, so this one is very similar to this one, but now we need to add the bot diameter. So in our window, which is 600 pixels wide, and our bot is 10 pixels wide, if this right here, this would be bot.x would be 590 plus the delta x, whatever that happens to be, plus bot diameter would be 10. So that means if this delta x is pushing it off of 590 plus 10, which is 600, and that goes over that amount, if it goes over the window width, then return true. And the easy thing is we can just copy that and we can change these all to y, because it is the exact same thing except with just y now. And not width, but height. Now, if any of those is true, then we want to move on to the next part of the run sequence. Otherwise, do nothing. So, update bots, it's going to come in, check destination, check boundary, update the movement. And we've got square root here. We do have imported square root. So this should work. Let's come over here and check it out. Okay, we've got small air. What did I do? Bot diameter. Bot, oh, I don't need bot diameter. I need bot dot diameter. Okay. Let's go ahead and try that again. Another air. What's it wanting? Oh, I still got that bot diameter somewhere in there. Where is it? There we go. Good. Okay, so right now, as you can see, all the bots are moving around. So let's try to follow one here. And you notice like this guy down here just going back and forth very, very quickly. This one's stuck on the wall. This one's stuck on the wall. This one looks like it's going to get stuck in the corner. That one, I don't know, going back and forth, a little bit spastic there. Eventually what you'll find, if you watch yours for a little while, is a large portion of them are going to get stuck in a corner, are going to get stuck in some repetitive process near a wall. The good ones, the ones that we want, the ones that are going to cover a lot more area, where more food will be, are going to be the ones centered here in the middle. But for the most part, you're going to get clusters all along the walls, and even more so in the corners. Alright, so you can watch it for a little while, you can see what it does. Different times you run it, you'll get different things, but for the most part, they're going to be in the corner. Alright, so that kind of covers the first part. Everything here is going to create your bots. The bots are going to move around. In the next big section, I'm going to create the world map, the food, and we're going to learn how to connect all that together so that the bots are actually going to be eating the food and everything like that. Okay, now, as I said, I'm not the best programmer. You might have found a way to make this run faster or do, I don't know, write it in 1/4 of the lines, and that's awesome. I'm writing this mostly for usability. If you'd like to share something, a better way of doing this, or maybe something that I missed, feel free to post it in the comment section, and I'll attribute it to you on the website, or if you upload a different version of the code or something, I'll be more than happy to post it on LeftPeel. Alright, thanks for watching, and I'll see you in the next video.